is my presentation. It's on generating synthetic data on the basis of metadata. And as Benjamin already mentioned, I'm part of a team that helps social scientists with their kind of data questions. And we started in 2020, and we've been helping a lot of people. And one of the things that we've been helping people with has been working with registered data from Statistics Netherlands. So that is just like microdata on individual levels, so very privacy-sensitive data sets where you have to get really difficult access. There's really great access control. And as I was working with these data, I got a little bit more convinced of the value of synthetic data, and that's what my presentation is about. So I want to go with you through a little bit of a conceptual background surrounding synthetic data. But in addition, then at the end, I will also show an actual implementation. So we're going to go conceptual and then practical. Right? That's what I hope to do. And I hope you will also generate a lot of questions in the meantime. I'm very excited to see what your opinions are and what your ideas are about it. So we are going to talk about synthetic data, what it is, why do we need it. We're going to talk a little bit about precision and privacy in the context of synthetic data. Then we're going to actually generate this from metadata, the DDI specifically, DDI codebook. I show a bit of an app. Then I have some thoughts / ideas about enhancing metadata, which is the topic of the session. Conclusions and questions as expected. Right. We have a lot of slides to go through, so I'm going to get through them. As a preface, I'm mainly going to be talking about what I call, as a statistician, I call that tidy data. And you might call it just rectangular data or just standard data set, a table, basically. We can call it X, for example. And there's this, it's just like on the right of the screen, you can see this, table, basically, where every column is a variable or a feature. Every row is an observation, and every cell is a single value. Now, if you're more interested in this tidy concept, you can read this article at the bottom. So let's talk about what is synthetic data. You may have a lot of preconceptions or ideas about what synthetic data is or means. I'm going to present you kind of from the point of view of a statistician who is very used to generating data sets for my work, basically. So synthetic data has a lot of different names. Some people call it fake data. Some people call it generated or simulated data. And it's kind of data that is, indeed generated as opposed to real, natural, or collected data. So if you go out and do a survey, you collect some data set, you can get your nice X, right? So your nice tidy data set after processing. But synthetic data is not collected, it's generated. In order to generate data, you need a process that generates this data. And this process, you can do that via probability distributions. You can take samples from a specific distribution. And I'm going to introduce some notation, but not too much. It's going to basically be limited to this, P of X given theta. And X here is the kind of the data, and theta is the parameters. And this P X given theta, it represents the distribution. So distribution needs parameters, and those parameters define what the data will look like. So, I mean, you may have a very statistical background, you may not at all have a statistical background, but I like programming things out to realize what things mean. And so I programmed it out for you in R. R is my programming language of choice. I do a lot in R because I'm a statistician. That's how it goes. And you can see those parameters, theta, here at the start. I call it mu, like the population mean, sigma, the population standard deviation. I put 1 and 1.5. And then with a single line of code, I can generate data. So for example, I call it x_sim here at the bottom. I can actually, maybe I can put like a pointer, laser pointer. Ah, there we go. So I have x_sim. That's going to be my generated data. I generated from a normal distribution generate 100 samples with a mean of mu and a standard deviation of sigma. So this whole thing is basically my probability distribution. So in order to generate data, I need a probability distribution and I need parameters. And then I can plot the value. So here is a histogram of x_sim, where the values are on the x-axis and the number of occurrences are on the y-axis, a standard histogram, right? So that's how I can generate some data. So this is what I understand as synthetic data. You can see this as a single column, basically. Right. So I have 3 take-home messages. The first take-home message is to generate synthetic data, you need a probability distribution and parameter values. You will always need this because otherwise, yeah, how are you going to generate? Next step is, okay, well, how do we choose these parameters? And something that's commonly done is we choose those parameters from existing real data that we want to represent, that we want to synthesize, basically. So you might have a real data set, and you want to say, now, actually, I want to create a synthetic version for privacy concerns or for some, for different topics. We will talk about that later. But you might want to not just set the parameters, as I've done here, mu and sigma, but you might want to learn those parameters from the data. And there are 2 packages that I want to mention. One is synthpop. It's made in the UK, and that uses a model called chained equations or trees, or there's several different models that it can use to learn the parameters from data, so that the data generating process, the model, statistical model, px given data, will represent the data very well, right? And then you can generate data from that, right? So this is a package to learn px given data, and x is then you put your real data set in to learn those parameters. And another one is synthetic data vault. It's a little bit more kind of machine learning. Their basic model is some copula model, but they also do generative adversarial networks, neural networks, variational autoencoders, all these kind of cool things that you can do to learn this probability distribution. But it's all probability distribution, no matter what method you choose in the end. So now we have a way to generate data. Now the question is, why do we actually need synthetic data? Right? What is it for? Well, I've written that down a little bit for myself. And what I've noticed that sometimes we cannot easily access the real data. For example, in the case that I mentioned before, is I work with data from microdata from Statistics Netherlands, and that's very access controlled, and you cannot just put it out there because then you could see what your neighbor earns, right? It's access controlled, it's privacy sensitive. So that's one thing, right? You cannot access the data. Sometimes, like me, I do have access for a specific project, but I might want to be open about the method that I'm using, and I want others to be able to understand my method. I may want to share my code, but if I only share my analysis code, what are the people who want to use it going to use it on, right? So I might be able to share my analysis code in addition to a synthetic data set that can be used to run that same code. Another reason could be that sometimes we want to look at the data only once after the analysis is set. So we want to develop our analysis on a synthetic data set and only run it once we've fully developed our analysis pipeline. And this avoids p-hacking and questionable research practices. It's actually been said as one of the large package of solutions to kind of the reproducibility crisis that we are in, for example, the psychology field. And sometimes we really kind of do not want to see the data or have it on a server. Maybe we want to just bring a script to someone's phone if they have very privacy sensitive data and only process it on someone's phone and then send only the results back to someone, right? So this is kind of like privacy friendly computing idea. So these are all cases for, like, if you would have then a synthetic data set, then you could develop your script and you could do that. So these are some cases. What else can you do with synthetic data? Well, something you can do with synthetic data is you get to know the data. This is really underappreciated, I think. If you have a synthetic data set, which is like fake data set, you can still inspect kind of the variable. You can load it into your program, whether that be SPSS, SAS, or R or Python, whatever you want. You can inspect the variables, you can inspect the values, you can know the size of the data set, which I call like the number of rows I usually call N, and the number of columns I usually call P. You can maybe have some idea about missing values. You can, you can do a lot already, right? You can create plots. So that's something you can do with synthetic data. Another example would be to use it as a toy example for teaching purposes, to try an analysis, different methods. I use synthetic data a lot because I do a lot of simulations to check whether my methods work well. It's basically synthetic data as well. And you could also write an analysis script, because if your code runs on synthetic data, it will likely also work on the real data. Maybe that's your goal in the end. You want to make some analysis on the real data. Another goal could be to reproduce analyses on the synthetic data and come to the same conclusions that you would on the real data, right? If you cannot get access to the real data, maybe you can make your analyses on the synthetic data and maybe you can come to the same conclusion. I hope that in the back of your minds, this already results in some kind of intuition that this is more difficult than using it as a toy example or getting to know the data. And that's what we're going to talk about next. But first, the second take-home message, which is know your goal. What are you going to do with the synthetic data? It's very important because it will determine how you need to generate the synthetic data. If you only need to get an idea of the data, that's a different goal than being able to reproduce completely the analyses and the results. So that's your second take-home message. Very important. Kind of small aside, if you just want to kind of get to know the data, you can use a Data Explorer from Scholar's Portal. On Dataverse, you can just like explore kind of the metadata files and fields and so on and so forth. There you can actually already see, how many cases are there, how many variables, what are the variable types, and this kind of stuff. So for this purpose, synthetic data is not really necessary, but it might be very useful to kind of get an idea in your computer program of choice. So you can go to that link if you are interested in that. But let's move on to the next part. Right. So now we've had this, like, what is synthetic data? What is the goal of synthetic data? Now I want to talk to you about something I've called the precision privacy continuum. I've only called it that because it alliterates. Don't actually take this as the actual name. There's better words for that. I will talk about that later. But precision privacy for all intents and purposes. So precision versus privacy. So precision, it's actually called usually utility in this field, but that does not alliterate, so I've just thrown away that term. Precision means how close is the synthetic data that I've generated to the real data. So when I run my analysis on synthetic data and on the real data, how close are my parameter estimates for my analyses that I'm interested in, and how close are my conclusions for my analyses that I'm interested in. That's precision. On the other hand, we have privacy. When I have the synthetic data generated by my model, how well can I reproduce the original data? This is sometimes called like a model inversion attack. Or how well can I determine whether a person was part of the original data? If I know everything about that person, how well can I know whether that person was part of the original data? That's kind of more going towards this differential privacy idea. How well can I estimate a specific person's income within certain bounds? If I have real data about income and then I generate my synthetic data, how well can I do that? Right? So that's kind of privacy. And what you have to realize is that conceptually, these are kind of competing, because every parameter in the data generating model, px given theta, right? Every theta element of theta in the data generating model, if it's learned from the real data, it contains information about the observations in the real data. And the more parameters you use, or information, the more information you use to generate the synthetic data, the more precise it will be. When the information in the parameters equals the information in the real data, we have just recreated the real data. And at that point, there's no more privacy or disclosure control. So, saying this in different words, if you have 999 data points, and you put a model on that with 999 parameters, then there's all the information in the data is also in the parameters, and you can theoretically you can reproduce the original data exactly. So at that point, there's no more privacy or disclosure control. Right? So this kind of puts precision and privacy at opposite ends. So if you increase the precision of your synthetic data, i.e. how well it looks like the original data, or how well your analyses reproduce the original those on the original data, then you decrease its privacy. And this is the third kind of really important take-home message. So let's look a bit at this continuum. How much does the synthetic data look like the real data? Well, on the one hand, we have, like, if it's very precise, if the synthetic data is really precise, we have a perfect imitation of the real data. It's like the values are exactly the same. That's when it's perfectly precise. On the other hand, if you're very private about your synthetic data, then actually the person has no clue what they're looking at when you look at only the synthetic data. And this concept is generally called broad utility. How well does the synthetic data look like the real data? Then another question we can ask is, how well do the analyses performed on the synthetic data reproduce those on the real data? Well, if you have very precise synthetic data, then 100%. You can run your analysis on the real data, you can run your analysis on the synthetic data, you will get exactly the same result. Same parameter estimates, same standard errors, same conclusions, right? If you're all the way on the privacy end, 0%. You can run your analysis, it's just random. There's just nothing in there that actually kind of reproduces the original analysis. And this is sometimes called narrow utility. Going a bit further is, how flexible does my data generating model, probability of X given theta, need to be in order to generate this data? So if you want to generate very precise data, your model needs to be very flexible. What do I mean by that? Have many parameters. And on the privacy end, you can be very inflexible, right? So here's some examples. Here on the flexible end, you can have this huge classification and regression tree that perfectly labels every data point. Or you could have some generative adversarial network with some privacy penalties, maybe some copula models. And if we go a bit more to the right, we have some kind of mice or synthpop, the package that I showed you earlier, some conditional specification. Very far on the right is just going to be independent univariate. So you just take for each variable, you just take a probability distribution and you just generate it like that. Then there's no information about relation between variables.
You have
and
5 minutes left.
It's just to put 0 everywhere. It's very inflexible. Then you're very private. Well, anything or nothing for precision and privacy for what you can do with the synthetic data. And I want to put your focus very much over here. So even if you're very private, you can still get to know the data. You can still use the data as a toy example. You can still develop and validate data analysis scripts in pipelines. And this is where I want to put your focus. This is where I think we can make a lot of progress. Because this privacy stuff is complicated, so I've come up with a trick: generate data from metadata, right? And that's why I'm here. If you generate data from metadata, there's no more privacy concern because the information in the metadata has already been released to the public. In the case of the Statistics Netherlands data, that's actually the case as well. Metadata should, of course, ideally be in a machine-readable format like PPI, XML, something like that. Our main application of CBS has PDF files only, so we are still working on getting that into machine-readable format. And metadata must contain variable-level information. Right? Another realization you have to make is that data-generating models have to be simple, because you can only do it per variable. There's no cross-variable information in metadata usually, right? It's just per variable. This is the variable type and the variable information. So here's the step program. 1, you get the metadata for your data set that you want to synthesize. Then for each variable, you determine the type. In DDI, that's kind of the var format. Then you determine the amount of missingness. You find a distribution that works. You set the parameters of this distribution from the metadata, right? The variable description has maybe some mean, some standard deviation, min, max, proportion, something like that. Then you generate data and you put it all in a nice table for the user. So that's what I've done. I've created a small prototype. I'm going to show you very quickly. There's a GitHub page, EDDI2021 I've called it. And there's a lot of information on there and how to run it also. And if you then run it, you get this view. And it interfaces with Dataverse. So if you have a Dataverse page, for example, this one, you can see metadata, you can export the metadata to DDI and so on and so forth. So that's really nice. And what this app does, if you copy this and you just put it in there, it will do everything for you. You say create data, and in the end, you get a beautifully synthetic version of the data set based on only on the metadata, right? And you can download it, and then you're very happy about it all, right? So that's something that you can look up. You can run it. It's just a prototype. It only works currently for continuous variables, and that's actually where I want to end on the kind of enhancing metadata. What would we need in order to make this better, right? To do more with this. And for me, I have, from a statistics background, I think about variable types in kind of the classic sense. They are actually related to these probability distributions that you choose for the variable type. So we have continuous variables, we have categorical variables, we have ordered categorical, string, character, dates, and times. And there's some parameters that are associated with those if you pick kind of the canonical model, data generating model. So mean, standard deviation, maybe the minimum, maximum, category labels, category proportions. Well, you can read all of that. That's something that you may be interested in. And for databases, even, we may even want to specify that a certain variable is a primary key if you want to link it to other tables, right? And then you could have as your parameter, that's just a thought that I had yesterday, you could have some kind of indication of possible values. For example, the student ID is 7 numbers from 0 to 9, between 0 and 9. Credit card number is 16 numbers between 0 and 9. So that's something you want to do. Right. What you could even do is generate summary statistics in a differentially private way. But I think I'm running out of time, so I'm going to skip this. If you're interested in this, by all means, talk to me. Conclusions are: synthetic data is generated from a probability distribution with parameters. It can have different goals, and you should know your goal in order to choose the right probability distribution. And it lies on a precision privacy continuum, and you should, with your goal, you can choose where on that precision privacy continuum you want to be. Metadata is privacy friendly and contains parameter values, generally about variables individually. And so automatic generation of data from metadata is really viable, or maybe even easy. And this EDDI2021 app is a particular proof of concept implementation. And as last conclusion, more variable level information may be needed for different variable types and to have like smartly deal with the different variables. So that was it. Thank you very much. I'm very anxious about your questions, and in a nice way, I'm excited about your questions. Here's some information of how you can contact me and the social data science team in the Netherlands.